Hello friends, in today's class we are going to discuss a file allocation method that is used in Unix by using inode. So welcome here, and we have already seen the allocation method and there is a linked, contiguous and indexed allocation method. Here we are talking about one situation which is require the very large file to be stored and a single index block may not hold all the pointers. Okay, what pointers will contain? Pointer contains address. Okay, pointer contained address of the block. Contains the file. Okay, following mechanism can be used to resolve this. One is your linked mechanism, and this came link two or more index block. Okay, it is not linking the two or more index block. Okay, so multi-index, index that is spanned into just different blocks holding pointers, and every index block will then contain the pointer to the address of the next index block. Multi-level index, that is one scheme. There is a multi-level index, and somehow you can relate this multi-level index in this way, that there is a outer index and then it is pointing to the index table, and then we have this our addresses. So this outer index contain address of next level index. So we can say that this contain address of next level index. Okay, so that is the idea here, and so that is multi-level index, and in this policy, the first level index block is used to point to the second level index block, which in turn point to the disk block occupied the file. This can be extended to 3 or more levels depending on the maximum file size. Very large file. This is used as a combined scheme, and in this scheme a special node is called the inode, information node. So that is the topic here, that combined schema, that there can be linked and index schema. Both are used here in this case, index and link schema, and it contains all the information about the file such as name, size, attribute, etc., and remaining pieces of the inode used to store the disk block addresses which contain the actual file as shown in the image below. So this is inode structure, that is mode, owner, timestamp, size, and now we have a direct block address. Okay, so the few of this pointer inode point to the direct block, that is the pointer contain address of the disk block that contain the data of the file. So now there is a direct block that contain the data for the file, and the next is the indirect block. Indirect, now it contain the directly data. Indirect block will contain the address of a index, single indirect, double indirect, or triple indirect. Single indirect is the disk block that does not contain the file, but it contains the address, disk address of the block that contain the file data. So like here we don't have like if I have a file, if I have a disk block, and so each disk block contain the data that is direct, containing the data direct, but each disk block contain the address of the data. Okay, now here we'll go the data, here we'll get the data, and here we'll get the data. Okay, so that is your single indirect. Similarly, double indirect will go to the block, then block will point to block, and then finally it will point to the data. That is a inode structure. Okay, so that is how it work, and it can go up to a triple indirect. Okay, so what is direct? Direct is basically directly pointing to this data. A single indirect will point to a block. Block will contain address of the data. Double indirect will point to the block. Again, it will point to the block, and it will contain the data. So this is one of the very common question asked from this particular topic. A unique style inode has 10 direct pointers. Okay, so we have 10 direct pointers. One single, one double, and one triple indirect pointer. One triple indirect pointer. This will also give you the entire idea about this. Disk block is 1 kilobyte. So now disk block is equal to 1 kilobyte and block address is 32 bit. Okay. So now I can simply calculate number of addresses. Number of address of what? Number of address of disk block. That is 1 kilobyte and divided by 4 byte. And that is 2 to the power 10 divided by 2 to the power 2, and that is 2 to the power 8. Okay, so 1 kilobyte and 32 bit is the information. So what is the maximum possible file size? The maximum possible file size is this. The maximum file size can have 10 direct pointer, and that is equal to 1 kilobyte. Then one single, and that will have 2 to the power 8, and that is equal to 1 kilobyte. One double will be 2 to the power 8 into 2 to the power 8 into 1 kilobyte, and then 2 to the power 8 into 2 to the power 8 into 2 to the power 8 into 1 kilobyte. Right, so that way if you calculate this, it will be total 10240 byte, and that will become 256 into 1024 byte, and this will become 2 to the power 8, 2 to the power 16. Okay, so it's 16 5536 into 1024 byte, and this will even become very large value here. Okay, 2 to the power 32 kilobyte. Okay, so now we can have this part is different. Okay, so this part is different, and now roughly I can say because others values are in factor, it will be very small here, that this quantity is very small. This quantity will be even small, this quantity will be a bit larger, and but this is of the magnitude of 24. Okay, sorry, this is wrong. This will be 2 to the power 24, and it will be 2 to the power 10 byte, and that will become 2 to the power 34 bytes, and that is approximately equal to 2 to the power 34 byte. Okay, so in this case answer is 2 to the power 34 bytes. Okay, so this is all. I hope you understand this discussion, that there is a one direct pointer, so directly 1 kilobyte, one single indirect, so 2 to the power 8 into 1 kilobyte. This is 2 to the power 8 into 2 to the power 8 into 1 kilobyte, and approximately I am saying the answer is 2 to the power 34 byte. Okay, so that's all for this discussion. Thank you.